So thanks for for this talk. That is last minute actually, and I didn't prepare this. Who attended my talk this morning already? Yeah, okay, so I don't need to introduce myself anyway, and nobody cares. Okay, so just this talk is about observability in general and tracing in particular, but still I need to have a small introduction in the beginning. So before we add observability, we talked about monitoring. And actually monitoring were a bunch of people looking at a screen wall with dashboards. And when something happened, well, they could try to fix the situation. But the problem is the systems become more and more distributed, and just looking at a dashboard is not super helpful. And so we had to come up with something new called observability, which sounds super nice, but actually is just like three things together: the metrics, the logging, and tracing. As I mentioned, I will focus on the tracing part, but I need to mention the metrics and the logging before. So the first thing, the metrics, I think this is something that we all know. If you don't know about metrics, if you don't do metrics, well, you need to leave this room immediately and start doing them, because then something is very wrong if you are like having a system in production without any metrics. Bad stuff, bad stuff. However, you could improve by not just like monitoring the base level metrics such as CPU, resources, disks, storage and stuff, just higher level metrics, like metrics that talk to the business. Number of requests per second, or even number of orders per second. That could be really, really nice. But again, as I said, normally it should be a solved problem. Logging, not so much. So here I will ask a couple of questions. I don't have a lot of definite answers, just to make you think. The first thing is what to log. When I was a young engineer, a young Java engineer, I decided I would create a Java agent that would log every input parameter of every method and log every result, return value. That was very smart, right? Well, not that smart, because yeah, I just logged also secrets such as password and stuff. So not that great, but beside that point, that was a very good ratio, right? I didn't do much. I wrote once and everything was audited. But the opposite should be the case. You need to like log explicitly what you want to log, and it requires a lot of effort and time. And just as you have code reviews, you should have like log reviews. When somebody write a method, hey, what did you log? How did you log? If there is a problem, do we have enough info to debug it? The logging format is also interesting because when I was a young engineer, yeah, I've been a young engineer before being an old engineer, we wanted to make the log human readable. But nowadays, probably you are pushing your logs to a centralized logging system, such as, I don't know, Elasticsearch. And in this case, you actually don't care about the log itself being human readable. On the opposite, you want the log to be machine parsable. And so because most of the time it's not the case, you need to go through an additional grokking system such as Logstash that will parse everything, the timestamp, the severity, the log message, whatever. This is an additional component that makes your system more fragile and actually takes resources and money. So my advice is just do write JSON directly. Where to log? Again, in the past, I was told never ever log on the console. You should log to files. And nowadays, we are using containers. You should never ever write to files. You should write on the console. So this is the fun part of the changing context. I mentioned you need to have a logging aggregation system. Stuff I'm less assertive about is scrape or send. Do you have an agent that scraps the logs from the system, or your application sends the logs? There are benefits and disadvantages on both sides. You need to evaluate them according to your context. As I mentioned, don't parse the log, just write the log that is already machine parsable. Now question, where do you store the log? How long do you store the log? Depends on your context, depends on the sensitivity of the data. Perhaps you need to purge them when they are in info and keep the warnings. It depends. You need also to think about the component that will search the log and that will display the log. So here there are a couple of systems that are available. As I mentioned, I'm more familiar with Elastic, but I believe all of them make the job. Now comes the tracing part. So I'm a big fan of Wikipedia definitions. In this case, I don't believe it's a great definition. So I came up with my own definition, and this is it. I won't read it loud, because you never should ever read your slides. And it's probably not by me, but it was inspired by many people. And it makes a lot of noise every time. And every time I see it and I look at you, no worries, that's fine. Now everybody looks at you too. I hope you are not shy. There were a couple of tracing pioneers, because the idea behind tracing is very important, and it's not something new. So you probably know about Zipkin and Jaeger if you have a couple of experience, and probably not so much about open tracing, but I will come back to it later. I knew it. The problem of all those systems is that they were proprietary. So the idea is that every time, right? Every time you need to have a component that is actually compatible with Zipkin if you are using Zipkin and Jaeger or whatever. So what we needed was a specification, but not the specification, you know, the XKCD comic, like we have 14 standards, we will unite them all, and now we have 15 standards. We needed a real standard. And I believe that W3C is a good body to have really a real governing standard. So they created the trace context specification, and it's actually quite digestible. The idea in this trace context is to define two abstractions. The first one is the trace, and the trace is actually the path of a business request across all the components of your distributed system. And then you have the span, which is bound to a component. And there must be at least one span, but there can be internal spans. So here is a diagram. You have, I lost it again, a single trace, right? And you have three components, X, Y, and Z. And X is the parent one, the first one, and then it calls Y and Z. So they are child ones, and every span is bound in a child-parent relationship. So every one of the span can trace their history back to a parent, then back to a parent, until you reach the first one, which has no parent. And then there is Open Telemetry. And Open Telemetry, it's like a Venn diagram with trace context. It adds some stuff, it implements some stuff. The first thing to understand that it's ready to be used. You have APIs, SDK, tools, whatever. So right now you can use Open Telemetry, and it implements the trace context specification. It's a merge of open tracing and open census. So I told you about open tracing just before. It's really, really nice. It's one of the few, if not the only one that I know, merging of open source projects that I know about. It's a CNCF project, it's open source, blah, blah, blah. How does it work? It gives you something very important. It gives you the formats and the protocol, to call an open telemetry collector. That's just what it defines. And that's very important, because now that it's defined, it's just a standard that everybody can implement. And very important, it offers an Open Telemetry collector. I will use the other one because I don't know why I always use the same one. It offers an Open Telemetry collector, but if you have a component that implements the Open Telemetry format and the Open Telemetry protocol, it's not a problem. So I have a couple of questions before on what database, how does it store? It's not part of the Open Telemetry standard, right? It's up to each implementation to decide how they will store the stuff. And the good thing is now Jaeger and Zipkin, they are compatible with Open Telemetry. Basically, you can keep your current tracing architecture and just switch on Open Telemetry on Jaeger and Zipkin, and you can afterwards add any component that is compatible with Open Telemetry, and all will flow through your current architecture. So this talk is more about how developers can use it. It's practical. So who here is a developer? Okay. You are not a developer. Yeah, you are too lazy. It's already late. I understand. That's fine. So I will assume you are all developers. That's great. How do you use Open Telemetry? There are basically two ways to use it. The first thing to ask is, what tech stack are you using? Does it provide a runtime? The JVM is a runtime, Python is a runtime, Rust, no runtime. If you have a runtime, the easiest way is through auto instrumentation. So depending on your stack, you will throw an agent or whatever and run your program through this hotel whatever, and you will get results out of the box directly. Very low effort and lots of benefits. If you don't have a runtime or you want to have more control over the results, then you need to have a library dependency. My advice is to use auto-instrumentation in the beginning because, again, the return over investment will be very good. So now comes the fun part, the demo. Here I have an e-commerce or a pseudo e-commerce stuff. So I have a home page and I ask for the product. So I will go through the API gateway because remember, you always need to have an API gateway in front. And then the API gateway will forward the request to the first component. The first component is a Kotlin Spring Boot application. And I want also not only to have the products, but I want to have the price of each product and the stock of each product, because if there is no stock, I don't want to display it. The pricing one is a Python Flask application, and the inventory is a Rust Axum application. And then for added fun, I want to have something async, so I print its analytics, and then I publish stuff on an MQTT queue, and then I have a Node.js app that subscribes to the queue and do whatever it wants. So I want to have everything like really, really traced. The most important stuff is the entry point. That's where you will generate the first parent ID and the basic trace ID. So here I'm using Apache API 6. Just something, Apache API 6 is an Apache project, as its name implies. It's based on Nginx, which is a very, very good and mature reverse proxy. The problem of Nginx, the open source version, if you want to change the configuration, you need to switch it off and on again. When something sits at the entry point of your information system, you want it to be always up, so not great. On top of that, you have OpenResty. OpenResty is a Lua engine that allows you to change the configuration dynamically, so it's hot reloaded. But at scale, it's hard to be maintainable, so we have API 6 that brings structures and concepts such as routes and plugins and upstreams. I will need your help, please. Maciek. Wojciech, sorry. Yeah, I call you brother, but unfortunately he's not there.
I know. That's a good escape.
Yeah, I need to, so I will, first I will start with the initial commit where I only have manual instrumentation. Docker compose up, and Docker is not there. Good start. Yes, it's there. Great. So who here is a Java developer? Okay, so I will show Java. Who here is a Python developer? Couple of hands. Rust developers? No. Half Rust developer. Copper developer. And Node.js developer? Okay, so I will show you Java and then whoever shouts the more. So the first thing is I have the catalog, as I mentioned. In my first version, I have Spring Boot application, and look, I have nothing related to Open Telemetry. Nothing. Now, when I build my container, that's where I put the stuff in. So here, I have, this is a multi-stage build, right? The first one, I will build the jar, and the second one, I will run it with a GRE. And before I run it with a GRE, I add these Open Telemetry agents, and I run it with the Java agent here. Okay? Then on the config port, I have API 6. Here, I configure the Open Telemetry plugin, and on the routes, I say, on every route, I will add Open Telemetry. Something very important, the sampler. In general, you don't want to sample everything. It would be too much data. For the demo, of course, I want everything sampled because I don't want to send 10,000 of requests to get one trace. And then I can add additional attributes. Now I curl the stuff. It's not very important. And now I can find the traces, and here they are. Thanks. Sorry. And this is it. Here you have your whole architecture, right? You have the API gateway, you have the catalog, you have the internal span inside of the catalog. You can see then the catalog calls the pricing through the API gateway, but it calls the inventory directly. So even if you are, sorry. Fucking weather. Even if you are not an ops person, even if you are an architect, thank you, it could be interesting to see, oh, this is not what I wanted, or this is what I wanted, right? Something interesting as well, you can see here that the call to the prices and the call to the inventory, they are run in parallel. Right? That's also something that I can validate because I was using Kotlin, I was using coroutines, but I don't know how good I am in coroutines. So here, it makes it validate my hypothesis that yes, it's right, I could call them in parallel. Something that could be interesting as well is also I can add additional data. I configured Apache API 6. Sorry. Yep. So I can pass a header, and I think it's X hotel key. And here I can say hello Java conf. And now if I come back here, I find the traces. The second time is always faster, right? And here you can have additional data. So here, this is the HTTP header, but as you can see, I also have the HTTP method that I asked for. On the Python side, it's very similar, right? You don't need to do, sorry, that's the Rust one. You don't need to do anything. My requirements.in is like just Flask and SQL Alchemy. But I do everything on the Docker file. So here I install the distro, the exporter, and here's something very interesting. There is a dedicated command line so that it will sniff every one of my dependencies that I've installed and install the right OpenTelemetry library that corresponds to it if it exists. So I don't need to think, oh, I'm using Flask, I need to install this one, it works out of the box. And just as in Java, here it's through the Open Telemetry instrument. You just don't launch Unicorn directly, you launch Open Telemetry, which instruments Unicorn. So we already have quite a few data points, which is super good, but we can do better. So let's try to do better. And I will add manual instrumentation. So I add manual instrumentation, and now on my Java app, on my Spring Boot app, I have added the annotations. So what does it do? I can add some more annotations to actually do two things. The first thing is I name the span as I want, because by default it was just the name of the method. And I can add spans, because here it was a private method, so there was no proxy in Spring, right? Java proxy, so it was not instrumented. So here I say I want this span to be instrumented as well, and I can add additional parameters. So here I want the product ID, for example. I already have the products, but unfortunately through annotation, I need to change the signature of the method just to say span attributes. So of course you can say, hey, here if you do like this, I can use the ID anyway. Yes, sure, now it's used, but still I wouldn't need it, unfortunately. So if I curl it again, and here I can also show you the Python stuff. So now I have added the Open Telemetry distro and exporter, and in the app I have dependency to Open Telemetry, and here I create a span directly, explicitly, and I call the stuff. So on Python I use the API, on Java I just used annotations because it works super well. And now if I go back here, and if I find the trace here, you have 26 spans. So here you have many more because I've added them manually. And here, for example, I have the fetch with the product ID. And we can see that here I'm looking for the product ID 1, and probably here the ID is also 1. Good. And also, if you're an architect, you see something very stupid, right? I want all the products, and then I call the pricing for each product independently, and the stock for each product, which is stupid. I should batch them, but still, it's a good use case for a demo. So we are nearly at the end, because the last, is there any question? Yeah.
So this is great for checking like individual traces.
Yes.
How would you analyze them? I mean, in the large scale. I mean, how would you find patterns in bottlenecks?
That's the thing. That's the part of your backend. And here, sorry, I'm using Jaeger, for example. And Jaeger, where is my compose? Here. This is this one. I'm using Jaeger. Why did I use Jaeger? Because there is one single Docker image. I don't need to know anything about Jaeger. I just need to say, hey, use OTLP. It depends on what you have behind, right? There are multiple ways to sample. The latest strategy about sampling, they will sample everything, and through ML or whatever, they will keep the one that are like strange, that are like anomalies.
Okay, but that would be focused on finding anomalies and not finding like the average and
Yeah, but what do you want to find in your traces? You want to find the traces that are anomalies. The thing that run normally, you don't care.
I mean, you do care if you want to optimize performance.
Oh, but here you have everything. In that case, you just take a sample of them, and you don't need this kind of like strange stuff. Here you can see everywhere how much time was taken. Be careful, huh? It's not like Dynatrace or something like this. It's not the same. So, because I understand that your question is more, hey, how I can use it like Dynatrace to have performance bottlenecks? It's not the same. It's just an ops tool to check the traces in the distributed system. If you want performance, it will probably depend on your backend, like the final backend, the Jaeger stuff. Yeah, you don't seem to be satisfied with my answer, so come back afterwards. We need to talk more. Yes? That's a very good question. Thanks for making me switch to the last step of my presentation. So everything that I've shown you so far is based on the HTTP header, the like transparent that contains the trace ID and the span ID. So you need to take it, the span ID as the parent span ID of the next span. It takes a bit of time. And now I will add the asynchronous queue, which is not HTTP at all. And for that, I found no library. So I had to write everything myself. So when we first started, right, the developers, they didn't need to know about Open Telemetry. In the second step, they needed to know a bit, and now they need to know everything, at least the API. That's what I did. So I will run it once more. I will show you, and then I will show you afterwards how I achieved this. So now we have 35 spans, 2 more. Where are the 2 more? They are here. Here you can see analytics filter, and here you can see analytics. This is a new component that I've added in my Docker Compose file. So here I have added the MQTT queue, and I have added the analytics. On the catalog side, I've added a filter, so that runs on every call to the API. And here I need to do everything by hand. So now I just not only need the annotations, I need the full-fledged API, and I need to find it here, Open Telemetry API. So once I have an API, I can use it however I want, which is what I did. So I'm using, well, the API, you don't need to care about it, but what I'm doing in a few steps, I'm like creating the span, setting the parent. The parent, this is, I'm able to like get the parent span. So automatically it will read the span from the HTTP header. So now I have set the parent, I add some metadata. Then I create my message, I publish it, and I end the span. And basically when I end the span, this is the time where the application makes a call to Open Telemetry, to Jaeger, to store the stuff. And on the, since there are a couple of Node.js developers, which I'm not, so please don't judge me too harshly. Or just don't judge me at all, it would be even better. Basically, I received a new message, I parse the data, but the data I don't care a bit. What I'm doing is I will be extracting the context with all the user's property that I have stored. What I'm doing, because I'm using the latest version of MQTT, I'm storing the trace parents as metadata. So when I publish the message, I store everything as metadata. When I read the message, I read it as metadata, and I can create a new span manually, setting the trace parent, the trace ID and the parent span ID manually. And then I can do the same as before. I start a span and I end the span. And this way, I'm able to have a complete trace throughout all the components, even the asynchronous one. And of course, if the component is not started, so I will just stop the component. Let's wait a bit. This one is super slow to stop because I think the container is not meant to receive sick terms. And I run it again. And here, I find the traces. So I have the second one. Here you see the analytics is not started. It doesn't receive the stuff. So I still have the trace. I still have the analytics filter, but I have nothing to receive it. And now if I start it again, it has started, it subscribes to the queue, it reads the message, and now normally it should be very, very strange. So here it has appeared. So of course, since it has taken a long time, everything is squashed on one side, and you can see it here on the other side. So this is how would an anomaly look. Either it doesn't appear or it's not in the right sequence. I think I told you everything I wanted to tell you. Well, you know who to follow on any network. Again, I have the demo if you are interested. And please check Apache API 6. And of course, you can read the talk. Now I have 3 minutes for questions. So somebody already started questions, so normally it should be easier for the next ones. That even if you are shy, second is always easier. No questions. Really? Is it because it's winter? Okay, thanks a lot. Enjoy the rest of the conference. And I still have a couple of stickers for people who didn't take them this morning.